The electrical system is primarily a 28-volt direct current system, supplying the majority of airplane electrical services. DC power is produced by two engine-driven DC starter generators and two transformer rectifier units. The power sources are supplemented by three nickel-cadmium batteries. The 115-volt alternating current variable frequency system is powered from two engine-driven AC generators. External ground power connections for the AC and DC systems are provided. The electrical system is controlled from the DC and AC control panels on the overhead console and is indicated on the MFD electrical system page. The AC variable frequency generating system provides 115-volt, three-phase power for AC systems that are not frequently sensitive, such as heaters, fuel pumps, and hydraulic pumps. Two generators supply power via a bus contactor to the related left or right bus systems. The generator control units regulate a constant output of 115 volts with a frequency output that varies from 340 Hz to 560 Hz depending on propeller speed. The AC generator output power is a three-phase 115-volt variable frequency generator with normal capacity of 34.6 kVA and an overload capacity of 42 kVA. The output frequency of the generator varies with propeller speed and ranges from 340 Hz to 560 Hz. Engine oil provides cooling and lubrication of the generator. An over-temperature switch within the generator stator windings closes and causes the AC generator hot caution light to illuminate in the caution and warning lighting panel. Each generator is governed by a generator control unit, GCU, which monitors output voltage of the generator, the feeder current, the internal generator current, and generator speed. These signals are used to vary the excitation field current of the generator to regulate generator output of a constant 115 volt per phase. The GCU also provides a protection for overvoltage and undervoltage, underfrequency, and bus fault protection. Operational status information from the other GCU is also provided. The AC electrical system can be monitored on the MFD electrical page. The voltage and the loads are displayed for each AC generator. The voltage indication shows the AC bus voltage for each phase, while the load indication shows the AC generator output load in numbers of percentage of the total rated output for each phase. A 1.00 indication is used to show 100%. A plus symbol before the number is used to show an overload condition of the AC generator. It is out of view when the load is less than 100%. When the voltage or load data malfunctions, the digits are replaced by white dashes. AC power is available once the condition levers are out of start and feather in the minimum 850 to maximum 1020 range, and the generator 1 and generator 2 switches are set to on, the AC generators are connected via their bus tie contactor to their related AC buses for normal operation. The current transformers in the AC generators supply current data to its related AC GCU to control its AC generator output. Whenever the AC GCU senses a source fault, for example an AC generator malfunction, It will automatically reconfigure the electrical power flow by closing the bus tie contactor to connect its bus to the other AC generator. The caution light of the failed generator comes on, and the galley load shedding relays open to de-energize the galley buses. The AC generators are protected from bus faults by the GCUs that detect any excessive load that might result from a short circuit on a bus. Once a heavy load is detected, the GCU isolates the bus and turns on the appropriate left or right AC bus caution lights. The number 1 AC generator hot or number 2 AC generator hot caution lights come on whenever an AC generator overheats. In this situation, the AC generator must be switched off. The AC external power energizes the 115-volt AC variable frequency system if no aircraft power source is available via the AC external power receptacle located on the inboard side of the right engine nacelle. The Electrical Power Protection Unit, EPPU, monitors the AC external power source that supplies AC electrical power to the 115-volt AC system. When the AC external source is supplying electrical power to the aircraft and the external power switch is set to the external power position, the EPPU will close the 2 cross-tie contactors and the 2 bus tie contactors to connect the external power source to the AC buses and to the transformer rectifier units to feed the DC electrical system. The AC external power system can be monitored via MFD electrical page. The message AC external power is displayed only when the following conditions are met. The AC external ground power is connected to the AC external power receptacle. The AC external power is good. The AC external power switch is set to the external power position, and the AC external power source is energizing the AC buses. The external power voltage is displayed in the AC generator voltage displays. The DC power system provides 28-volt DC power for operation of the aircraft DC electrical services and also provides the starting power for the engines. The sources of DC power are 2 DC starter generators, 2 transformer rectifier units, and 3 batteries for supplementary power and engine starting. The system can also be supplied by a ground power unit or an APU with starter generator. The system is controlled from the DC control panel and can be monitored at the MFD electrical page. The DC power system is controlled from the panel in the overhead console. The panel contains the battery switches and the generator switches. With the main bus tie switch, the main feeder buses can be connected manually. In case of a bus fault, they may be reset with the bus fault reset switch. The DC external power on annunciator is displayed on the MFD electrical page. On the MFD electrical page, the voltage of the buses can be monitored. The battery annunciation area indicates the load and the temperature of the main, auxiliary, and standby batteries. The battery load display is expressed in a percentage factor. A readout of 1.00 indicates full load and equals 100% load. A plus or minus sign indicates whether the battery is in overcharge, plus displayed, or in discharge, minus displayed. The battery temperature display indicates the battery temperature in plus or minus degrees Celsius, when the temperature is within normal limits. When the temperature is in the range plus 50 degrees Celsius to plus 65 degrees Celsius, the digits turn yellow. When the temperature exceeds 65 degrees Celsius, the digits are displayed in red. The DC bus voltage annunciation area indicates the voltage of the left and right essential bus, the main bus, and the secondary bus. Generators 1 and 2, TRU 1 and 2, and when installed, the APU. Loads are displayed in their respective displays and are expressed in a percentage factor. A readout of 1.00 indicates full load and equals 100% load. A readout of 0.50 indicates half load. A reading of 1.20 indicates a 20% overload. An overload condition is also indicated by a positive sign. The DC power bus system consists of the main feeder buses and secondary feeder buses, which are located in the DC contactor box. The essential buses and the main and secondary distribution buses are located in the flight compartment. The main feeder buses are powered by the respective generator, and the secondary feeder buses are powered by the TRUs. The feeder buses are connected to the respective distributor buses, where the power is distributed to the electrical systems of the aircraft. If no other supply is connected, and the battery master switch is set to the on position, contactors will close, and all three batteries will supply power to the essential buses. By selecting the standby battery switch to on, selecting the auxiliary battery switch to on, the auxiliary battery supplies power to the left main feeder bus. And by selecting the main battery switch to on, the main battery supplies power to the right main feeder bus. During an emergency DC main bus fault condition, contactors will open to disconnect the standby, auxiliary, and main batteries from their related main feeder buses so that only the essential distribution buses stay energized. With both engines running and selecting both generator switches to on, the generator bus contactors will close. The main and essential buses are powered by their associated generator. The batteries are charged by the main feeder buses. Three diodes prevent charging from the essential buses into the batteries. The secondary buses are powered by the TRUs. In case of a generator failure, the GCU opens the generator contactor and closes the main bus tie. The remaining generators will load both main buses. In case of a second generator failure, the second generator contactor and main bus tie opens. The main to secondary bus tie closes on both sides. The left buses are now powered by the left TRU and the right buses by the right TRU. If in this situation a TRU failure also occurs, the main to secondary bus tie will open and the secondary bus tie will close. The secondary buses will now be powered from the remaining TRU and the main buses will be de-energized. When one TRU fails, the secondary bus tie closes. The remaining TRU now powers both secondary buses. When the second TRU fails, the associated TRU contactor and secondary bus tie open, and the main to secondary bus tie closes on both sides. The left buses are now powered from the left generator, and the right buses from the right generator. When in this situation a generator failure occurs, the main to secondary bus tie opens and the main bus tie closes. The main buses are powered from the remaining generator and the secondary buses are de-energized. The EPCU and the DC GCU's protection function protect the DC subsystem against short circuits on the main and secondary buses. If a main bus fault occurs, the EPCU prevents the main and secondary feeder bus ties from closing to isolate the bus. The DC bus caution light comes on to warn of the fault impending condition. If the fault persists after approximately 5 seconds, the EPCU sends a trip signal to the GCU, isolating the affected generator. The EPCU will also open and lock out the contactors connecting the batteries to the affected main bus. The affected battery caution light and related DC generator caution light will come on as a result. All main DC services on the faulted bus side will not function. Note: manual operation of the main bus tie through the main bus tie switch is not possible once the EPCU has reacted to a fault. In the case of a secondary bus short, the overcurrent condition will immediately trip the associated TRU primary circuit breaker. The EPCU then senses a TRU source fault and causes the secondary feeder bus tie contactor to close after 7 seconds. The high current condition causes the cross-tie fuse that protects the other TRU from the effect of the bus fault to open. The DC starter generator is used for engine start and to generate DC power. The generator is rated to 300 amperes and 30 volts. An internal 4-blade aluminum fan provides cooling through the air inlet on the non-driven side and exhausts the air at the driven side. A thermostatic switch in the generator activates the generator hot caution light in case of an overheat condition. The DC Generator Control Unit, DC GCU, located below the co-pilot's circuit breaker panel, controls the DC starter generator start and regulation modes. The DC GCU senses the DC starter generator speed and stops the start mode when the speed of the engine is more than 50% NH. At the end of the start mode, the DC GCU opens the bus contactor and de-energizes the DC starter generator. The DC GCU regulates the DC starter generator's output and provides the following protective functions: overvoltage, differential feeder fault detection, bus fault detection, and parallel load sharing. The Electrical Power Control Unit, EPCU, located below the pilot's circuit breaker panel, automatically controls the operation of some contactors in the main 28-volt DC generation system, or manually controls contactors by flight compartment toggle switch selections. For example, a manual external DC power selection causes the EPCU to close the external power contactor. Automatic functions are used to reduce pilot workload and to start protective functions. For example, the EPCU automatically causes the external power contactor to open when it senses an overvoltage condition. The DC Transformer Rectifier Unit, TRU, located in the nose compartment, is a self-contained solid-state power conversion device that changes 115-volt variable frequency AC electrical power to 28-volt DC electrical power. The TRU receives three-phase 115-volt AC power through a circular connector on the front face of the enclosure. The output, 28-volt DC power, is available through positive and negative studs, also located on the front face of the enclosure. The TRU supplies an indication of its status for indication in the flight compartment through the EPCU. The DC Contactor Box, DCCB, assembly located in the rear nose compartment is used to distribute and control the main 28-volt DC electrical power. The box has covers to allow access to the internal line replaceable units, LRUs. The electrical power connections between contactors in the DCCB are made with bus bars. The DCCB has circuit breakers to protect the feeder cables that are routed directly to the aircraft equipment or to the circuit breaker panels in the flight compartment. The DCCB contains the following components: DC starter generator bus tie contactors, main feeder bus tie contactor, secondary feeder bus tie contactor, DC external power contactor, current transformers, and DC circuit breakers and protective fuses. The Standby Contactor Box, SBCB, assembly located in the forward nose compartment is used to supply electrical power to the powered rear elevator and battery buses in the flight compartment. The SBCB has circuit breakers to protect the feeder cables that are routed directly to the aircraft equipment or to the circuit breaker panels in the flight compartment. The components in the SBCB give control and distribution of the DC power source from the standby battery. The SBCB contains the following components: DCMP power contactor, main bus contactor, essential bus contactor, and circuit breakers. The DC current transformers located in the center fuselage section are electromagnetic components used with the DC GCU to sense differential feeder fault protection. The DC current transformers are used to monitor the DC starter generator power feeder cables, which pass through a hole in the DC current transformer. When a DC GCU senses the voltage in one DC current transformer is different than the voltage in its related DC current transformer, the DC GCU de-energizes the DC starter generator and the line contactor. The current shunts supply-output current data from the left and right TRUs, left and right DC starter generators, and batteries to the EPCU for indication. The TRU and battery current shunts are located in the nose compartment shelf near the TRUs and batteries. The DC starter generator current shunts are located in the center fuselage section. The battery power system of the aircraft has 3 nickel-cadmium batteries located in the nose compartment. The main and auxiliary are 40 ampere-hour batteries. The standby can be optionally a 17 or 40 ampere-hour battery with an assembly of individual cells contained in a steel case. Each cell is connected in series to make 24-volt DC at the terminals. The battery system is controlled with the battery switches at the DC control panel in the overhead console. The contactors to connect the main and auxiliary batteries are located in the DC Contactor Box, DCCB, and the contactors that control the standby battery operation are located in the standby battery contactor box in the nose compartment. The batteries are connected to the main feeder buses to receive charging current. The main and the auxiliary batteries are also connected to the main feeder buses to supply electrical power to start the engines. During an engine start condition, the standby battery is disconnected from the main feeder bus, but stays connected to the essential buses to maintain a minimum voltage level on the essential bus. During an emergency condition, the batteries are the electrical power sources for the main 28-volt DC generation system. The essential distribution buses stay energized by the standby, auxiliary, and main batteries. The emergency mode is caused by the conditions that follow. Electrical power is not available from the two DC starter generators. And electrical power is not available from one or two TRUs, and the aircraft is airborne. The batteries have two independent internal sensors that sense battery temperature. A thermal sensor supplies battery temperature data to the EPCU for EIS indications. And a bimetallic temperature switch supplies temperature exceedance data to the caution and warning system for warning indications. The APU DC generation system provides 28 volts DC to the main, essential, and secondary DC buses while the aircraft is on the ground. The system consists of a DC starter generator, a generator control unit, a control panel, and the associated relays and monitoring circuitry. The generator is mounted on the reduction drive housing of the APU. Generator cooling air is drawn from the intake by an integral fan in the generator and is dumped overboard through the generator exhaust duct. As soon as the APU reaches 95%, the APU run relay energizes. By selecting the generator switch to on, the GCU switches to generator function and closes the APU bus contactor. APU power is now supplied to the right main feeder bus. The generator on light will illuminate. The main bus tie and the main to secondary bus ties are energized to supply the whole system. The GCU regulates the output voltage and current by varying the field input. With the APU generator supplying the DC system and external power connected and selected on, the APU GCU receives DC external power signal from the EPCU and opens the bus tie contactor to disconnect the APU DC generator from the right main feeder bus. When the DC buses are energized by the two DC starter generators and APU power is selected, the APU bus tie contactor closes to connect the generators in parallel. System monitoring can be performed via the MFD electrical page. The DC bus voltage annunciation area indicates the voltage of the left and right essential buses, the main bus, and the secondary bus. The APU load is displayed in the digital display and is expressed in a percentage factor. A readout of 1.00 indicates full load and equals 100% load. A readout of 0.50 indicates half load. A reading of 1.20 indicates a 20% overload. An overload condition is also indicated by a positive sign. APU faults. The APU system can detect a fault, isolate the APU, and supply protection. The system will protect and shut down the APU. The APU system monitors overspeed, underspeed, start failure, accelerate failure, EGT over temperature, low oil pressure, high oil temperature, failed sensors, failed valves, relays, and circuits, and internal failure. If an APU fault is detected, the APU automatically shuts down. Fail segment of the APU power switch light, amber. APU fuel valve closed advisory light, white. APU fuel valve open advisory light, out. APU caution light, amber. Whenever the APU generator reaches temperatures above 149 degrees Celsius, the APU will be automatically shut down. The generator hot caution light and APU fail light come on. Two external power systems are provided in the Dash8, a 28-volt DC external power system and a 115-volt AC external power system. The systems are controlled by switches on the DC and AC control panels. When external power is available and the systems are switched on, a green annunciation, external power on, will illuminate on the MFD electrical page. Both connectors are enclosed by hinged access doors. When the battery master switch is selected on, DC external power is connected and is switched on. 28-volt DC electrical power is supplied to the left main feeder bus. The DC GCUs receive a DC external power signal from the EPCU to cause the bus tie contactors to disconnect the DC starter generators from the left and right main feeder buses. The main feeder bus tie contactor closes to energize the right main feeder bus, and the secondary main feeder bus tie contactors close to energize the secondary feeder buses. After the engine start sequence, with the DC starter generator switches set to the generator 1 and generator 2 positions, the DC GCUs will prevent the DC starter generators from connecting to the main feeder buses. The DC external power switch must be set to the off position to cause the DC starter generator bus tie contactors to close. This connects DC starter generator power to the right main feeder bus and left main feeder bus. The EPCU incorporates external DC power protection from too high or too low supply of external DC power voltage. If the external voltage is more than 31 plus 0.5 or minus 0.75 volt DC, or less than 22 plus or minus 1 volt DC, an over-under voltage condition will cause the external ground power to stop supplying electrical power to the aircraft. The left and right essential buses stay energized because the battery operation is independent of the EPCU. If the external power over-under voltage is rectified, the external power source can be reselected by moving the DC external power switch to off and then to external power. DC external power voltage indication can be monitored via the MFD electrical page. The DC bus voltage indication shows the DC bus voltage for the essential, main, and secondary buses. In case of a voltage data malfunction, the digits are replaced by white dashes. When external power is selected, the number 1 DC generator or number 2 DC generator caution light comes on to show that the generator is not connected to its bus because an external DC power source is energizing the left and right main feeder buses. Note, there's no indication for a condition where the DC external power source is connected to the aircraft and a DC external power switch selection is not made. The AC external power system supplies 115-volt AC electrical power from an external ground power source to the aircraft 115-volt AC variable frequency buses. When the AC external source is supplying electrical power to the aircraft, the battery master is selected on, and the AC external power switch on the AC control panel is set to the external power position. The ePPU will let the external power source connect to the AC variable frequency buses. The ePPU automatically controls operation of the cross-tie contactors by monitoring output voltage, frequency, and phase rotation of the AC external power source. When the ePPU senses an external power malfunction, it will cause the cross-tie contactors to move from the external power position to de-energize the AC buses. The AC GCUs control the bus contactor operation. When the AC GCU receives an AC external power signal, it causes the bus tie contactors to move to the external power position. When the AC buses are energized by the AC external power, the AC generators are disconnected from the AC buses. AC external power voltage indication can be monitored via the MFD electrical page. When selected on, the AC external power annunciation is displayed and the AC bus voltage indication shows the AC bus voltage for each phase in white numbers. In case of a voltage data malfunction, the digits are replaced by white dashes. When external power is selected, the number 1 AC generator or number 2 AC generator caution light comes on to show that the generator is not connected to its bus because an external AC power source is energizing the left and right buses. Note, there is no indication for a condition where the AC external power source is connected to the aircraft and an AC external power switch selection is not made. The AC external power receptacle, located on the left side of the right nacelle of the aircraft, is used to allow repetitive connections to an AC external power source. When an external ground power connector is connected to the receptacle, it will supply 115-volt AC from the ground power source to the AC buses. The aircraft AC power receptacle is a 6 male pin connector. The External AC Power Protection Unit, EPPU, makes sure that good AC external power is allowed to energize the AC buses. The EPPU checks the external power source for the parameters that follow: overvoltage, undervoltage, overfrequency, and underfrequency. The DC external power receptacle, located on the left side on the forward fuselage section of the aircraft, is used to allow repetitive connections to a DC external power source. When a DC external ground power connector is connected to the receptacle, it will supply 28-volt DC electrical power from the ground power source to the DC buses. The aircraft DC power receptacle is a 3 male pin connector. Circuit breakers, CBs, are used to protect the AC wiring to the aircraft loads. The circuit breakers are protection devices that open the circuit during excessive current flow. The 115-volt AC variable frequency is supplied through the 115-volt AC variable frequency circuit breaker panel, located on the aft right bulkhead in the flight compartment. The 115-volt AC variable frequency, three-phase buses, and their related circuit breakers are identified on the panel. The AC electrical load is distributed from the variable frequency AC generation system from two internal and one external power source that follows: AC generator 1, AC generator 2, and AC external power. The DC electrical load is distributed from the following DC power systems: main 28-volt DC generation system and battery system. The main 28-volt DC generation system has 5 internal power sources and 1 external power source. These are the left TRU and right TRU, the DC starter generator 1, the DC starter generator 2, the main auxiliary and standby batteries, and the DC external power. DC electrical load from the DC power sources is supplied to the aircraft equipment through the following circuit breaker panels: the left DC circuit breaker panel, located on the top surface of the left circuit breaker console behind the pilot's seat. It contains the left main and secondary distribution buses and the left essential bus. The right DC circuit breaker panel, located on the top surface of the right circuit breaker console behind the co-pilot's seat. It contains the right main and secondary distribution buses and the right essential bus. And the avionics circuit breaker panel, mounted on the aft left bulkhead of the flight compartment, above and behind the left DC CB panel. It distributes 28-volt DC to avionics and audio equipment.